Hello Math 45 students, this is your instructor Cindy Enrique, and we are going to wrap up section 6.8. So we are starting on page 30, and we have our exponential regression. So exponential regression is used to model situations in which growth begins slowly and then accelerates rapidly without bound, or where decay begins rapidly and then slows down to get closer and closer to zero. We use the command exponential regression on the graphing utility to fit an exponential function to a set of data points. This returns an equation of the form y equals to ab to the x. So here are the instructions of how to perform the exponential regression. What we've already done was linear regression and quadratic regression. And now we're going to continue with our exponential regression. So here in particular, we are looking at our exponential regression. So here are our steps. So we're going to be making sure that we use our graphing calculator for this. So for example, down below, it says use the data below to determine the exponential regression for the values of a retirement account over 50 years. So we are making sure that we plug this into our calculator. So I actually downloaded the calculator app, so I think you can see it. Okay, here we go. And I also have my steps over here, so you can follow along on your calculator and see what I'm doing on my calculator as well. So it says use the stat and then go to edit. So I'm going to go to my stat. That's what I do first. And I want to go to the edit, so I'm going to make sure that I press enter. From there, my L1 values, I'm going to go ahead and plug in my X values, okay? So my X values are 0, 10, 20, 30, 40, and 50. So all of the X values go into my L1. So here is my L1. And my L2 is going to be all of my Y values. So I'm going to make sure I go to my L2. Let's see if I can do this. Okay, so now I'm in my L2. And I'm going to go ahead and plug in my values. So I have 10, I have 52, I have 176, I also have 423, I have 694, and I also have 1038. Okay, so now I have my L1 and my L2 values in here. So now from here, what I want to do is I want to go ahead and get my exponential regression. So I am going to go to now I'm reading these directions here. I want to find the equation that models the data. So I'm specifically going to go to my stat. I'm going to go over to calculate. Now I'm going to go all the way down until I see my exponential regression. So my exponential regression is here at 0. So I'm going to press enter on my calculator. Now I'm going to keep pressing enter until I get to calculate. And then I'm going to press enter one more time. And now it tells me my values for my A and my B. So make sure that you guys see that. So I don't know, maybe I'll round to the 3 decimal places. So I am going to have that my y is equal to a times b to the x value. So remember, I still have that, but apparently I can't show that screen and write at the same time. So my a value is 17.885. So my a value is equal to 17.885. And my b value, remember, I'm going to go ahead and go to the 3 decimal places. So 0.095, and that 3 tells me to leave it alone. So okay, so my b value is equal to 1.095. So to put it all together in my format, I am going to get that my y is equal to 17.885 b, which is my 1.095 to the x power. So that is going to be my answer on how I get my exponential regression, okay? And I just did that using my calculator, okay? All right, so now for part B, it specifically says, hey, estimate the value of the retirement account on the 52nd year. So part B, I want to estimate what happens at the 52nd year. So here, my time is going to be equal to 52. So that's what I'm going to be plugging into my equation. So y is equal to 17.885 times my 1.095, and my x value that I'm plugging in is going to be 52. So I'm going to go ahead and plug that into my calculator. Okay, so I'm going to have my 17, oops, it's so tiny, so 17.885 times my 1.095 to the power, and my power here is going to be 52, and I plug that in, and I get my value of 29.24. Okay. And you can see here that I actually entered in one too many zeros. So I'm going to try that again. So that's really nice about the calculator, is that you can see that I actually made that a little too small. So maybe if I make my screen a little bit bigger, I'm able to see it. So I should really have 17.885 times 1.095. There we go. So the first attempt that I did it, I had one too many zeros. And now I have 1.095, which is what I had before. And it's to the 52nd power. And now I get the correct answer of 2004. So I'm going to go ahead and write that down. So then my value, my y is equal to my 2004. So 2004,000. Since my units are in thousands. Okay, now I'm going to go into my second equation here. So for this one, now I have my logarithmic equation, okay, or my logarithmic regression. So I'm going to go ahead and notice that my logarithmic equation, it actually has the word of ln. So ln is the log regression. Okay, so that's something to be careful about. So all right, here we go. So we have our instructions and we have our data. So it says use the data below to find the log regression relating to the value of an antique car over 20 years. And you're just like, okay, so if it's talking about the log regression, I know on the calculator, I'm going to be looking at my linear or ln regression. So ln regression, natural log regression. And I know that the general equation is really going to be that y is equal to a plus my b times my ln of x, okay? That's going to be my general. And that's what I have here, right? A plus b times ln of x. So a plus b times ln of x. So I have my x values and I have my y values. So this is my L1 and this is my L2. So my x and y values. So again, I'm going to use the calculator and I'm going to go ahead and clear it. So I'm going to go to my stat. I'm going to go to my edit. And now I'm going to clear these values. So I'm going to go up where I see L1, press clear, and go down. Then if I go over and do the same thing where I'm highlighted at L2, press clear, and go back down, it clears my data. So now I'm here at L1, and I'm going to plug in my values. So I have 50, I have 55, I have 60, 65, and 70. So 50, 55, 60, 65, and 70. So for my L2, I have my 30, I have 50, I have 75, I have 80, as well as 96. Okay, so 30, 50, 75, 80, and 96. Those are the values that I have them for my L1 and my L2. So since I'm finding my logarithmic regression, I'm going to go to my stat. I'm going to calculate. And I'm going to go down until I see my ln regression. So ln regression, oops, is here as number 8. So we're going to go down to number 8. So now, oops, not number 8, that's linear regression. Number 8 is linear regression. Number 9 is logarithmic regression. So there's a key difference between LIN and LN. So make sure that your logarithmic regression is LN, okay? That's going to make a huge difference. So now I'm going to press enter. And I keep pressing enter until my values show up. So now I have what my A value is going to be, and I also have what my B value is going to be. So let's go ahead and round off to 3 decimal places. So my A value is going to be negative 725.897. So I'm going to go ahead and write that down. So I have that my A value was equal to a negative 725.897. And now my B value, if I round to 3 decimal places, it's 193.794 because that 9 tells me to bump it up. So 193.794 is going to be my B value. So my B value is going to be my, I guess I have to write it down, 193.794. Let me just double check. Okay, now I have it. So now I'm going to rewrite my general equation. So I have that y is equal to that A value, which is at negative 725.897, plus 193.794 ln of x. And that is going to be my final answer. Okay, so that's it for this section. So it was very short and sweet. We just had 2 examples. So it's all about making sure you know how to use your calculator. Okay, you guys, well, if you have any questions, please feel free to email me or the Math Success Center for more help. Thank you.